Hi guys, this is Mrs. Gastler, and in this video we're going to talk about pulses and waves. We've got our handy Cornell paper here. We're going to fill out our topic and objective is pulses and waves. Over here you're going to put your name, class period, and date. Our essential question is what's the difference between a pulse and a wave? Let's get started. Remember, this is a YouTube video. You can stop and pause or speed up and slow down the video as you need to. Make sure you stop and ask questions if you need to understand what something means or figure out what I have written down. That would be helpful too, okay? So to begin with, waves and pulses are traveling energy. Energy is the key word here. Only the energy is what's transferring. The particles stay there when the wave travels. These are called mechanical waves. We'll only be doing mechanical energy, mechanical waves at this point in time, mechanical waves. There's non-mechanical waves, which you might get to later on, maybe not, depends on what you choose, okay? Only the energy is transferring. This is kind of wiggly up here, sorry about that. Both are caused by disturbances. Waves and pulses are both caused by disturbances, so it really kind of depends on what's happening there. Pulse is a single disturbance, so there's only one. There it is, just one single disturbance right there, and a wave is many disturbances, consecutive, one right after another. There's a little blip, just ignore that, that's not there, okay? One right after another, there they go. They keep going for one right after another, okay? How do they transfer that energy? Well, it's kind of the same from a pulse to a wave, but there's a couple of different ways that they might do that. One, the particles are with forces and the energy, they're touching each other, so they're going to be pulling and pushing, which we've already learned about, right? Pulling and pushing. That's going to transfer that energy from one particle to the next, and there's two ways that they do that. One way is called transverse, and in that case, the particles move across the wave or the pulse, okay? To draw a picture, if the energy is going to the right, like this, the particles in the wave or the pulse particles, they're going to go this way, up and down, and that's the one that I drew up there. It looks like this, okay? Looking at some visuals, there'll be some links that you can look at to see these, some moving images, some GIFs, depending on what you call them, in Schoology that you can take a look at to see the difference between a transverse and the other one here. To see what those look like, it's much easier to see them in a visualization than to draw them, okay? A longitudinal, the particles move along the wave or the pulse. In this case, the energy, if it's traveling the same direction like this, the wave or the pulse particles, they'll be going along it, so that would go like this. They'll go back and forth like this. They'll bump into each other, kind of like dominoes or people in the hallway, okay? When we draw that, it's not quite so easy to draw, but the particles will spread out and get closer together like this, and spread out and get closer together, and spread out and get closer together. Again, this one is going to be much easier to see in a visualization, which you can look at in Schoology, so see Schoology for that. Some other words that we use for this one, we like to use the word perpendicular because they're at 90 degrees. And for this one, we like to use parallel because they're the same, okay? Perpendicular, parallel, across, along, same, across, various words there too. Transverse, longitudinal, okay? And that's it that we're going to be writing down today. So if you have any questions, make sure you ask your teacher. Thanks for watching.